Dynamic programming. I thought this was an interview for Walmart. Thank you. What's up, guys? It's Taylor. Welcome back to The Blueprint, a channel in which we talk about software engineering principles, and sometimes I build things. Sometimes, but not today. Today we're actually going to talk about whiteboarding. And it's okay if you've never heard of whiteboarding, or if the thought of whiteboarding just fills you with a sense of existential dread.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
No problem. I got you. I promise that by the end of this video that I'm going to set you up with a framework that's going to help you smash every single whiteboarding interview that you can ever have. All right, let's get it. So the very first step in smashing a whiteboard interview is that you have to be in the correct mindset. So what I mean by that is you can't be thinking about what you're going to eat for dinner. You can't be thinking about every single whiteboard interview you failed before this. And most importantly, you can't be thinking any of that imposter syndrome, like you're not good enough, none of that. You got to be in the zone, focused on the actual problem. So make sure you get a lot of sleep, make sure you're hydrated, drinking water, whatever you need to perform at your peak level. And then step 2 is to actually make sure you understand the question that the interviewer has given to you and that you check your toes. And toes is an acronym that I created, and I'll explain a little bit later. But more importantly, make sure you understand the question. If your interviewer is asking you to reverse a linked list and then return the contents of the linked list as a string, make sure you actually reverse the linked list and then give the contents of a string. So many people get super excited with a simple problem and that they don't listen to everything that's required of them and only complete half of the problem. Don't be that person. And the second thing is, like I said, you just want to check your toes. So toes is an acronym that I created, and it stands for techniques, outputs, and edge cases. And I'm actually going to go over in the reverse order. So edge cases are variables or scenarios that can cause your code to break. So for example, if your code is doing some division, for example, and 0 happens to come up, you cannot divide by 0, and that will break your code. There's different edge cases for different problems. For example, if you're dealing with strings, what happens if there's an empty string or null string, etc., etc. The whole gist of this is that you want to think of situations that will cause your code to break before you write the code. That way you can make sure to handle them or think about what you're going to do about them before you even get started. So the O actually stands for outputs, and that goes back to my example that I gave you earlier about reversing the linked list and returning the contents as a string. It's a second portion to the problem. You must return the contents as a string. So make sure you're actually giving the interviewer the output that they want. Sometimes they will just want a simple number, sometimes they'll want an array or whatever. You want to make sure that you're giving them what they ask for. So T is just techniques. These are essentially just tools that you've learned over time that help you solve problems. So some examples of this might be recursion, or 2 pointers, or helper functions. And these are just things that you have used before to help you solve problems. So you want to make sure that when you're thinking about these problems, that you understand exactly what the problem is asking you, and that you can think about some techniques that you already know that might help you solve the problem. And that leads us directly into step 3, which is to create a game plan or a roadmap for you and the interviewer. And so you're going to do this by creating an actual really simple graphic, with triangles, squares, lines, arrows, whatever works for you. You don't have to be Picasso here. You're essentially just creating a actual visual of the code. So I'm going to give you a little example here. Let's say you want to reverse a string. So the first thing you might want to do is get the length of the string. And then the second thing you might want to do is maybe create a string builder object. So you're going to actually list out what you're going to do in your code, but you're going to do it in blocks that make sense. Now, you don't actually have to write code here. You can write pseudocode, or you can just write down a quick note. It's just essentially explaining to the interviewer what you're planning on doing. This is very important because this sets the stage for you actually writing the code. And this allows the interviewer to see, hey, maybe there's some flaws in your logic, or maybe they can say, oh, this problem is too simple. You already know how to do it. Let us, up the ante. Oh, hell no! Or do a separate problem. This also allows you to, flex your skills and show off here. Maybe you know how to solve this problem in more than one way, and you can actually create, some simple diagrams of the other way and ask the interviewer which one they'd like to see, This step is really crucial. It's very important, and I wouldn't skimp on this step. Don't take too long here. I wouldn't say more than 5 or 10 minutes drawing the diagrams, but this, like I said, it's very important and it sets the stage. So step 4 is to actually just write the code. Now, if you are in the correct mindset, you understand the question, you know your techniques, and you have a game plan, this step is actually really simple. A lot of people freak out when writing the code, but this is because they did not do the previous steps. If you have a roadmap, then you already know essentially what you're doing. So the only tips that I have for you here is to write legibly. Make sure your variable names are short, especially if the code that you're writing is long. And then the final thing is to make sure you're talking while you're writing, because essentially you're just reading off that game plan that you wrote, but it just allows you to stay in the same mindset and make sure that you don't forget anything. So step 5 is to actually test your code. And that's important too, because you might have forgotten something. There may be an error in your logic, and it's way better if you catch your own errors versus the interviewer having to point them out. So if you're using integers or floats or things like that, maybe try some positive numbers, try some negative numbers, try 0, see what happens. If you're using strings, try long strings, empty strings, null strings, uppercase, lowercase, just different combinations. You don't have to test super extensively, but definitely do it, and definitely test more than one output. If in the case you find there is an error in your code or there is a bug, point it out. Like I said, it can't hurt. They probably already knew that it was there. And then of course ask, like, hey, do you want me to rewrite the code to, acknowledge this bug so I can fix it? Or, hey, do you want me to just, ignore this, pretend like it isn't here, and continue on with the question. The interviewer will let you know what they want you to do. So step 6 is to just turn in your code, turn around, say, I'm done, what do you think? And at this point, you're kind of going to stop talking, and your interviewer is going to start asking you questions. And so they might ask you questions about why you chose to do this versus this, what's the runtime, what's the memory, etc., etc. They're essentially just going to pick apart your code, and they're going to ask you to defend your code. And that's going to be a little bit scary. And the only advice that I really have for you is to just listen to their feedback and kind of just get used to talking about your code. It's really not that scary because you wrote your code and you know why you wrote your code. So just let that shine through. And then step 7 is also really simple as well. Just rinse and repeat. Oftentimes, coding interviews have more than one problem that build upon each other. So make sure you follow the same 6 sequence of steps, or even 7 if there's another question, and you'll be good. So, I'm just gonna, repeat them again for clarity to make sure you guys have a framework and can use it. Get in the right mindset. Make sure you understand the question fully. Check your toes. Create a game plan for you and the interviewer. Write your code, write it legibly. Test your code and submit it. Do it all again. Rinse and repeat. And that's it. Super simple. Well, I guess you must have liked this sort of content because you're still here. And you're in luck. I'm actually creating an entire series in which I'm going to solve whiteboarding questions step by step in a way that's super easy and clear for you. And if you're interested, I'll just leave a link to it over here, maybe, or down in the description box. You can just totally go ahead and click on it and, dive into the whiteboarding fun. Choose yours. See ya.